Today we are finishing up section 6 by going over simplifying complex rational expressions. So first, what are complex rational expressions? Basically, a complex fraction is a fraction that has fractions in it. Oftentimes, they look very scary, and if you have a fraction with fractions in it, it is not considered simplified. So we're going to learn how to deal with that today. So here's our first example. You can see here we have a fraction and it has fractions in it, and this is not considered simplified. So first thing that we're going to do is we're going to identify what the least common denominator is of this fraction by looking at the little fractions inside the big fraction. So basically I'm going to use these denominators here to identify the LCD. So it needs a factor of m and it needs a factor of n. So there's my LCD. And now I'm going to do something very different than we did yesterday. I'm going to actually multiply the top of this fraction by the LCD, and I'm going to multiply the bottom of this fraction by the LCD. Because when I do that, again, I'm really multiplying by 1 when I do that. It's just a fancy number 1, written as mn over mn. And you'll notice we have to know where the big fraction bar is in our problem, because we multiply the top of that big fraction by the LCD, and we multiply the bottom by that same LCD. And when you do that, on the bottom here, you have to make sure you distribute that to both of these terms. And then on top, I'm going to do mn times the top. So when I multiply both the top and bottom by mn, I get 3mn on top. And then when I multiply mn by 1 over m, you multiply the numerator by this number of this little fraction, and then the denominator stays the same. That's how you multiply a whole number by a fraction. And then I'm also going to multiply mn by this fraction 1 over n, so the top becomes mn, and the denominator is still n. Now at this point, I can simplify these little fractions here because they have a similar factor on top and bottom. So m over m is 1, so I can cross those out, and then n divided by n is 1, so I can cross those out. When I do that, I get the following. 3mn over, on the bottom I'm left with n plus m. And there is my simplified fraction. And there's no common factors to cancel, so I'm done. And for this lesson, we're not going to worry about finding exclusions for these problems. Let's move on to example number 2. Example number 2, I've got 1 over x minus 1 over 1 over x plus 1. First thing I do is I'm going to identify what the least common denominator is. So the LCD needs a factor of x. And then from this fraction, it needs a factor of x, but it already has one. So that's it. That's my entire LCD. So again, we are not trying to make common denominators here. What we're going to do, this is a different strategy than we were using for adding and subtracting, is I'm going to multiply the top and bottom by x. And again, pay attention to where that big fraction bar is. It's right there. So I multiply the top of the fraction by x, and I multiply the bottom of the fraction by x. And when I do that, you need to make sure you multiply the entire top by x. So you need to distribute that x to there, and distribute that x to that term, and to that term. So when you do that, x times 1 over x gives you x over x. And then x times 1 is x. On the bottom, x times 1 over x is x over x. And then x times 1 is x. Now, with these little fractions, we can simplify by crossing out any common factors on top and bottom. And when you do that, this doesn't just go away. When you do x over x, you're really changing them both into 1s when you cancel them. So this now becomes a 1. And then I still have minus x. And on the bottom, I've got a 1 plus x. And that's as simplified as this gets. There's no other factors that can be canceled, so there's my final answer. Now let's move on to example number 3. I've got 4 plus 1 over x all over 3 plus 2 over x squared. So I'm going to start by identifying the least common denominator. The least common denominator needs an x. It also needs an x squared. Well, it already has one x, so all it needs is another one. Because now the LCD is x squared, you'll notice that x squared is taken care of, and so is that x, because this x squared has a factor of x in it. So I'm going to multiply the top and bottom of this fraction by x squared. Okay, so again, when you do that, don't forget to distribute. So give that x squared to both terms on the top. Multiply that by x squared, and that by x squared, and on the bottom, multiply that by x squared, and that by x squared. So when you do that, you get 4x squared plus, then x squared times that will be x squared over x. And on the bottom, x squared times 3 plus x squared times that will give you a 2x squared over x. Now, cancel any common factors. Oops, that should be an x squared down there. Cancel any common factors, so you can see down here I've got an x squared over x squared, so those cancel. Here I've got an x squared over x, so I can cancel one of them. That x cancels with one of those, leaving me with an x right there. And now I've got 4x squared plus x over 3x squared plus 2. And then we should check to see if there's anything that can cancel. I don't see any common factors right now, but I still need to actually factor the top. So I'm going to factor out a GCF of x, leaving me 4x plus 1 on top. And on the bottom, that doesn't factor at all, so it's just 3x squared plus 2. And you can see there's no common factors there, so there's nothing I can cancel. And there's my final answer. All right, now let's move on to example number 4, I think. All right, this one's a little bit better. Here we go. First thing I need to do is identify my least common denominator. Now to do that, I actually need to deal with this a little bit, because this can actually be factored right here. So I actually need to start by factoring this denominator. So that denominator right there, y squared minus 4, factors into y plus 2 times y minus 2. And then on the bottom here, nothing needs to be done. There's no factoring to do, so I'm just going to copy it down. Now I'm ready to identify my least common denominator because it needs both of these two factors from that denominator. So y plus 2 times a y minus 2. And then it needs a y plus 2. Well, it already has that factor. And it needs a y minus 2. It already has that factor as well. So now I'm ready to multiply by my least common denominator. So I multiply the top by y plus 2 times y minus 2. And I multiply the bottom by y plus 2 times y minus 2. So I just need to multiply this fraction by that. And on the bottom here, I need to distribute to both of those terms. So when I do that on top, I will get y plus 2 times y minus 2 over y plus 2 times y minus 2. On the bottom of this fraction, I need to distribute that to both of these terms. So when I multiply it by this, I get y plus 2 times y minus 2 over y plus 2, and then plus, and then when I multiply this term by that LCD, I get y plus 2 times y minus 2 over y minus 2. Now, there's a whole bunch of stuff to cancel. Y plus 2 over y plus 2 is 1. Y minus 2 divided by y minus 2. There's a y plus 2 divided by y plus 2. And then a y minus 2 divided by y minus 2. And you can see that I'm just left with, well, everything on the top canceled, meaning that just becomes a 1. And on the bottom, I'm just left with a y minus 2, and then plus, and then y plus 2, which I can then simplify. Y plus y is 2y, and minus 2 plus 2 is 0, so that's it. There's my final simplified answer. Alright, let's see how you're doing. You try this one. Go ahead, hit pause, give this a try, and then hit play again when you're ready to check your answer. And there it is. That's what your work should look like. The LCD you identified as n plus 4, multiply top and bottom, distribute on the bottom, cancel common factors. You should get 1 over n plus 4 minus 1, and of course 4 minus 1 becomes a 3, and there's our final answer, 1 over n plus 3. And let's go on to our final example here. This one's pretty similar to the last one with one special thing we got to look out for here. So first, I'm going to identify the LCD. That's just an x plus 1. And that's the same denominator, so it's just an x plus 1. I multiply the top and bottom by the LCD of x plus 1. On the top, make sure you distribute that x plus 1 to both terms. On the bottom, it's just x plus 1 times that one term. So, on the top, I get x plus 1 over x plus 1 minus, and then x plus 1 times 1 is x plus 1 over, and then down here I got an x plus 1 over x plus 1. And now you can see there's a lot of x plus 1s that cancel. So I get, don't forget that becomes a 1, minus, and then x plus 1 over, and that becomes a 1. But there's one major mistake I just made, and that is, back here when you do x plus 1 times 1, that's actually being subtracted. The entire x plus 1 is being subtracted. That needs to be in parentheses here, because we need to actually subtract the entire binomial, not just the first term like I have here. So I actually need to distribute this minus sign through the binomial so that I'm left with a minus x, and then this positive one right here, when I distribute that negative, actually needs to become a minus 1. So be careful for that. Look out for when you're subtracting a binomial, you need to distribute the minus sign to both terms. Now when you simplify it, you have to do 1 minus 1 is 0. And so you're just left with the negative x on top. And then it's just over 1. So that's the answer right there. Negative x. And that's it for simplifying complex rational expressions. Be careful with how you're using the LCD. Again, this is a different strategy than yesterday for adding and subtracting. We're still identifying the LCD, but we're doing something different with it. I'm not making common denominators. I'm using the LCD to multiply through by the top and bottom